Thyristor. Turn on thyristor method. Turn on process of a thyristor is a dynamic process in which the device voltage current simultaneously vary with time. Okay. Turn on is a process describing the transition from forward blocking state to the conduction state. Transition state called the thyristor. Turn on time is defined as a time during which the changes from forward blocking stage to the final on state. Total turn on time of SCR is equal to the sum of the delay time, rise time and spread time. Okay. Total turn on time is depend upon the anode current parameters, gate signals amplitude and a gate signal rise time. Full stop. The term on the time is of under 2-4 microsecond. ठीक है. A forward bias thyristor can be turned on by number 1 forward voltage triggering, number 2 gate triggering, dV upon dt triggering, temperature triggering and light triggering. So these methods are used to increase the leakage current in forward bias thyristor. It initiates the regeneration, ultimately leading to turn on the thyristor. From these 5 on method, gate triggering and a light triggering are recommended. ठीक है. So number 1 forward voltage triggering. In this method, gate current, that is Ig, is equal to 0. Anode is at the positive potential with respect to the cathode. Anode voltage is increased to breakover voltage VBO, and this method is known as forward voltage triggering. In practice, this method is not employed because it required a large anode to cathode voltage, and also large current generation occurs. It can cause damage in the thyristor. In this method, avalanche breakdown occurs. Number 2, gate triggering. Gate triggering is a simple, reliable and efficient method. At a desired moment of turn on, a suitable positive gate voltage is applied, and this results in a gate current. As the value of Ig, gate current, increases, required anode cathode voltage decreases. Gate current magnitudes are of the order of 20 to 200 mega ampere as shown in the figure. This is a gate current and forward breakover voltage like this. Source voltage VBO and gate current. Variation of breakover voltage with respect to gate current. Once SCR current conducting, gate current is no longer required. As we know, from the starting moment we need gate current. After that, when the SCR started conducting, gate current is no longer required, and that gate current may be removed after firing the SCR. Simple. In a gate current is removed before raising anode current and attain to the launching current value, and the thyristor will return to the forward blocking state. And this problem mainly rises with the individual load, and 3 types of signals can be used in this purpose. These are either DC signals, pulse signals or AC signals. The gate current circuit is also called as a firing circuit. These are lower part of electronic circuit. Gate trigger circuit commonly consisting of a power supply, pulse generator with synchronizing command and feedback signaling, pulse amplifier and pulse transformer. These pulse transformers clamping circuit that is used. Okay, the figure name is a general layout of a gate control circuit. Okay, next is dv upon dt triggering. When anode to cathode voltage is positive, outer junction J1 and J3 get forward bias and inner junction J2 is reverse bias junction behave as a capacitor. Charging current of the capacitor depend on the rate of a rise forward voltage, and if forward voltage is suddenly applied, then charging current would be large, and due to this phenomena SCR turn to on state. However, this dV upon dt turns on and has to be avoided, and the rate of change of applied voltage is kept below specified rated limit. Next one is next triggering is a light triggering, and also known as a radiation triggering. Light can be used in the term on SCR by causing breakdown of a junction J2 with the junction J1 and J3 forward bias. Okay. In light triggering SCR, gate region of the light is sensitive material. When light ray is appropriately wavelength and intensity fall on the gate region, then the gate current increases. It causes forward biased SCR to turn on. SCR turn on to the light radiation is known as a light activated SCR, that is also called as LA SCR. Okay, and here there is a 3 figures. Okay, I'll show it to you. Next one is a gate control method. Okay, what is gate control method? There is a 3 type of a signal can be used to gate triggering, and they are either DC signal or AC signal or a pulse signal. Okay, DC gate triggering means in this type of triggering a DC voltage is a proper magnitude and the polarity is applied between the gate and the cathode. When applied voltage is sufficiently to the produce required gate current, the device starts conducting. Simple. In this method, power circuit and the trigger circuit are DC, so there is no isolation between both circuits. Another drawback is to continuous DC signal has to be applied. And AC gate triggering, what is AC gate triggering? In AC gate triggering, AC source is most commonly a gate signal and signal in all application of Thyristor control AC application. This scheme provides the proper isolation between power and the control system, control circuit. The firing angle control is obtained very conventionally. By changing the phase angle of the control signal, the drive is maintained for 1/2 cycle after a device is turned on, and the drawback of this scheme is that they separate the required to step down the AC supply. Next one is your pulse gate triggering. What is pulse gate triggering? What is the method of pulse gate triggering? This method is most commonly used. In this method, the gate drive consists of a pulse gathering circuit. High frequency pulse are applied, and this is known as a carrier frequency gates. The pulse transform is used for isolation and gate losses are minimized. Okay. Gate pulse is obtained from relaxation oscillator circuit, which may be consist of UJT and PUT. PUT, programmable unijunction transistor. shows the circuit diagram for synchronizing UJT triggering circuit here. Okay, I'll show you this. I'll show you like this. Hello friends, in previous video we see thyristor turn on method, and there are a total 5 turn on method of thyristor. Okay, now in this video we see the thyristor turn off method. Okay, the turn off method of the SCR may be defined as a minimum time interval between the instant of anode current becomes 0 and the instant of the device capable of blocking the forward voltage. The turn off time is a combination of a reverse recovery and the gate recovery time. The thyristor recover the reverse blocking property during the reverse recovery time and forward blocking property during the recovery time. And the turn off time provided by the turn off circuit, that is commutation. Commutation circuit must have more than SCR turn off time by the suitable margin, otherwise commutation failure occurs. Turn off time depend on the following factors. Number 1, junction temperature. Number 2, forward anode current. Number 3, rate of decay of forward current. Forward blocking voltage. Number 5, external gate impedance. Number 6, positive gate bias voltage. Number 7, peak reverse current. And number 8, reverse voltage. Okay, and types of commutation. There are two main types of commutation method, natural commutation and forced commutation. किसी चीज़ को बंद करने को बोलते commutation, ठीक है, जो एनोड से करंट को फ्लो करने के बंद किया जाता है. Forward commutation method is further classified into the resonant commutation, self commutation, auxiliary commutation, complementary commutation and external pulse commutation. There is the फर्स्ट जो मैंने आपको बताया दैट फोर्स कम्यूटेशन मेथड. तो उस मेथड में सबसे पहले मैंने बोला रेजोनेंट मेथड. रेजोनेंट मेथड को बोलते हैं क्लास ए मेथड. ओके, क्लास ए कम्यूटेशन. सेल्फ कम्यूटेशन को बोलते हैं क्लास बी कम्यूटेशन. ऑक्सिलरी कम्यूटेशन को बोलते हैं क्लास सी कम्यूटेशन. कॉम्प्लीमेंट्री कम्यूटेशन को बोलते हैं क्लास डी कम्यूटेशन. एक्सटर्नल पल्स कम्यूटेशन को बोलते हैं क्लास ई कम्यूटेशन. ओके, फर्स्ट वी सी क्लास ए कम्यूटेशन, मतलब रेजोनेंट कम्यूटेशन को देखते हैं. दिस मेथड ऑफ कम्यूटेशन इज ऑल्सो कॉल्ड एज अ रेजोनेंट मेथड. एज आई से, द कम्यूटेशन component L and C are connected in the series with load, thyristor and a power supply. Okay, in this method the current flow through the SCR and is reduced to a neutral zero due to L and C component. And class B commutation, that is self commutation. Class B commutation, in this method of commutation it also known as a self commutation. In this method the thyristor turn off by the action of resonating LC circuit, but the commutation method and L and C do not carry load current. Initially the capacitor gets charged to the battery voltage with the upper plate being positive. As soon as thyristor is turned on, current flow through the thyristor and the load resistance. Now capacitor start discharge through the inductance and the thyristors, and after getting completely discharged it start getting charged in the opposite direction and the charging current reverse. This negative charge opposes the load current. When the load current and the opposing current are equal, then the thyristor is turned off. Of class A commutation and commutation element carry load current, but that is not so in the class B commutation. Okay, now class C commutation. In this method commutation is also called as auxiliary commutation. Okay, commutation element are inductor, capacitor and the auxiliary thyristor. Some of initially when T1 is turned on, the current flow through the T1 and the load capacitor get charged due to the current flowing through the diode and the inductor. Okay, to turn off main thyristor T1, auxiliary thyristor T2 is turned on by applying the gate pulse. So the capacitor C appear across the T1. Voltage of the capacitor is of opposite polarity, and this reduces the current through T1 and T1 turn off. As this method use capacitor voltage to commutate the main SCR, so it is called voltage regulation. Okay, now our class 4th number, class D commutation, and this class D commutation method is a complementary commutation method. This circuit consists of a main thyristor T1 and complementary thyristor T2 in the parallel to T1. The triggering of a one thyristor turn off other thyristor. ठीक है, when T1 is turned on, current flow through the load I and T1, and also the current flow through the load 2 capacitor and T1, and this current of the charge with the right side of the plate of the capacitor is positive, and the T2 is turned on, and the capacitor of the voltage that appear reverse bias across T1, and this turn it off, and now the current flow through the load 2 and T2. In addition of current, current also flow from the battery through the load I, capacitor and T2. If T1 is turned on by the external gate pulse, then voltage across C appear in parallel with the T2 with opposite polarity of T2 turn off, and this method of commutation used in inverter. Okay, second, class E commutation. Class E commutation, in this method is also called as external pulse commutation. In this method, reverse voltage is applied to the current carrying thyristor from external pulse source. Pulse transformer is used to apply commutating pulse. Voltage at a secondary of the pulse transformer appear across the thyristor T1 as a reverse voltage and turn it. Okay, there is a figure, you have to see that figures. Last commutation method is class F commutation method. It is an AC line commutation method. If supply in an alternating voltage, load current flow during the positive half cycle, and during the negative half cycle the SCR will be turned off, and the duration of the half cycle must be large as compared to the turn off time of SCR. Okay, then it is a natural commutation. It does not require any additional elements. This method is used to control the rectifier circuit. So here we complete 2 topics. First topic is thyristor turn off method and thyristor turn on method. So in this video there is a 2 topic is completed. So thank you for watching my video. Share it, like it and subscribe it. This is the power electronics and drive 3rd year diploma course in electrical engineering semester 6.